I'd like to show you how to interpolate in the Excel environment. So of course, it's my hope that you've got some background in why do you need the skill of interpolation in the first place. We'll try to cover a little bit of that as well. So let's get started. So this is a little screenshot sort of in the Excel environment of some tabular value where you're going to try to interpolate between two values. And this is a little bit of a formula. We'll cover that, the details of this formula in a second. And so I want to cover with you, how do you do this in Excel over and over again? Because the chances are mighty good that certainly within your classes and then beyond your classes in engineering practice, you're going to be interpolating values thousands and thousands of times. Now, another thing to be aware of is I want you to be sure that you can cover all your bases. You want to fully understand how to interpolate using your calculator, because that's going to be the way that you must do interpolating calculations in quizzes and tests. So it's my understanding that you would not be using Excel or MATLAB or any of the other computational PC platforms in a quiz or a test. So you've got to be sure that you can do this on your calculator, let's say with the little calculator routine as well. Okay, and so with a little background, if you want to learn more about how to interpolate, you need to learn a little bit more. Let me show you how you could download a PowerPoint presentation. It's on how to interpolate to maybe reinforce your understanding. So let's see. I'm going to jump out of Excel real quick, or PowerPoint. I'm going to let's go to Jay's Toolbox on your browser, jaystoolbox.vt domains. And here's the main screen. And let's scroll down to search, and let's just type in interpolate and search. Okay, and so this particular one, how you click on this link, how to interpolate, and it'll take you right down to the ability to download a PowerPoint on how to interpolate. Let's go back to screen. And then I'm going to be doing some live demo in Excel. And if you click on Interpolation Demos 2022, that is going to enable you to download the Excel file where I'll be working this out live. Okay, now I guess my trick is to get back to, let me try to get back to PowerPoint. Yikes, I think I made it. Okay. So a little bit of a crash course, just as a reminder on what's the basic, how would you set up a formula in your mind and on paper and then in Excel to set up an interpolating formula. And so here's going to be the example problem that we're going to work out. I have a pressure cooker that's sitting on the stove, and it's running, it's got water, H2O in it, and we're adding heat. And I want to know, and the pressure gauge is reading 324 kPa, 324 kPa. And I'd like to know what the boiling temperature is inside this pressure cooker. All right, so let's go back for Common Sense 101 of things that we all know already. How about when there's a pot on a stove and it's open to the atmosphere, so you know that the pressure of the water on the pot is atmospheric pressure or 100 kPa. Your common sense tells you that you know, without sticking your finger in or a thermometer in, you know what the boiling temperature is of boiling water at 1 atmosphere or about 100 kPa. It's about 100 degrees C. You've been taught that all the way back to elementary school. 100 degrees C is the boiling point of water at 100 kPa, 1 atmosphere. Now for our problem at hand, we've got a boiling, we've got a pressure cooker. We see the pressure gauge and it reads 324. And I happen to have a table of boiling point temperatures logged against various pressures. And I've got 133.6 at 300 kPa. and I've got 138.9 degrees C at 350 kPa, but my pressure gauge is 324. How do we determine what that boiling point temperature is? We've got to interpolate this tabulated data. All right, and so now how would we create a formula? And so this is a little bit of my handwritten scratch work where I work things out with a calculator with pencil and paper. And so I'd say this is sort of informal. We're looking for Y2, aren't we? Let's think about what did we have? We had something like X1 and Y1 tabulated, and we have X3 and Y3 tabulated. Those are known numbers. But we want to know what Y2 is at X2. Okay, that's our trick for interpolation. So we can come up with a formula. And so that formula informally is, well, we know that Y2 is going to be at least Y1, plus it's going to be some proportion of the difference between Y3 and Y1. How would we figure out the proportion? So Y3 minus Y1, I've got that in there. The proportion, well, the proportion is, we're going to look over on the X side, and we're going to look at this difference, X2 minus X1, divided by the entire difference, X3 minus X1. So do you see that this expression here, X2 minus X1 in the numerator, divided by X3 minus X1 in the denominator, that's the proportion of the X interval that we will apply to at least Y1. I've tried to do sort of the same thing in the Excel environment, and this is a screenshot of what's in that how to interpolate and also the Excel interpolation file. Okay, so it's a little more formal. It says that Y interpolated, or I should say Y desired, equals at least Y1 plus, well, X known, what we're looking for, minus X1, the upper value, denominator X2 minus X1, that's the entire span, okay? And then that gives us, that numerator and denominator gives us our proportion or ratio, and here is the maximum possible span, Y2 minus Y1, that will apply. So I hope that that gets you comfortable with understanding the hows and whys of interpolation. And so here's my signal to go live into Excel. Okay, so we'll remember our problem. We have a pressure cooker. We have a gauge on the pressure cooker, and we can read the pressure, and it's 324. And we're trying to figure out what's going on inside that pressure cooker pot of H2O. We know then that the temperature, the boiling temperature, is going to be somewhere between 133.6 and 138.9, but we want to quantify it. What is that value? Okay, so I'm going to escape out of here. I'm going to minimize. I'm going to go to Excel. And now here we are in Excel, and here is my table. So I've gotten a table of boiling point temperatures. I don't want to confuse you, but let me jump to the next tab in this file so I can show you. Where did I get those numbers? Well, this is a set of thermodynamic properties that I have downloaded from your thermodynamics text, and it's called pressure table. And so rather than getting all down in the weeds, I've clipped out a little bit of that data, and here it is for our demo. I'm trying to prompt myself on now, what do I need to do to show you how to set up an interpolating formula in Excel and maybe use it over and over and over again. So here's what we'll do. Let's label our columns. I'm going to label P for pressure and T. Okay. The next thing I think I'll do here on these two cells, I'm going to box them out, and I'm going to click center so that I've got my little labels are centered. Okay. The next thing I do is, okay, where is my problem at hand? My problem is hand, 324 kPa. I've got to look through my table, and I've got to select the right numbers to fat finger in these cells. Okay, so here, I'm somewhere between 300 and 350. So let me type in 300 here. okay? And then I'm going to skip a row and I'm going to type in 350 for pressures. Now, let's see, I'm going to go back and enter the temperature according to 300. 133.6, 133.6, and then 138.9. Now, okay, so we're getting there. Okay. Here's what I'd like to do. Let me box this out and let me turn these yellow, because effectively, do you see that I fat fingered those in? So if you've been watching some of my previous videos, that's great practice to turn yellow, turn cells yellow that you fat finger a number in. Here's what we're looking for is 325. I'm going to fat finger that in and color it yellow. So I'm almost there now. And this is consistent with my little cheat sheet, okay? Now let's come up with an Excel formula to determine the interpolating method, all right? And so rather than, we don't even have to cheat, you're welcome to kind of look, but let's see if I can figure that in my head. I'm going to start with the equals. That starts the formula, equals. At least some amount, it's at least 133.6. So I'm going to click on that cell B15, put it in there. Okay, plus. The next thing I want to do is work on that ratio, the numerator and denominator ratio or proportion of what we're going to add to that difference between Y3 and Y1. So I'm going to start my parentheses for the numerator. And let's see, what is the numerator? It's this number. I'll just click it. Minus this Y1 number, close parentheses, divided by, now for the denominator. Set my parentheses up. Now let's see, what was that? It was this number, turns out to be A17, minus this number, close parentheses. Okay, that's the numerator denominator of our proportion, times what? That span, the temperature span. I'm going to close parentheses, and the temperature span is this number, 138.9 or B17 minus this Y1 number, close parentheses, enter, and there is my Excel formula. Does it make sense? So let's see, does the table make sense? Wow. For 325, look at that, 325 is halfway between 300 and 350. And with a calibrated eye, do you see that, gosh, 136, that's about halfway between 133 and 139, makes sense. Now, I'm going to go ahead and put a box on here. And another thing I'm going to do for my work, notice how these decimal points do not line up. So I'm going to light up all three of these cells. I'm going to click on the number formatting tool, number, and I'm going to adjust my decimal places to, let's call it 1 or 2, whichever you like. I'm going to make it 1. All right. And so now let's make it 2. Why would I do that? Why am I wavering? I'm wavering because that gives me 1, 2, 3, 4, 5 significant figures. That's sort of on the ragged edge of what we'd like. But if I'm going to copy this over, say, to pencil and paper somewhere else, that gives me that sort of 5th significant figure that makes me feel a little more comfortable than working with only 4 significant figures. But certainly 8 significant figures, that's a waste of your time, and it's ineffective. And you say, okay, well, this is great, but I could have done this with a calculator instead. Well, what if you're doing a homework problem, and then all of a sudden the instructor changes his or her mind and says, no, oh, I didn't, look at that. I'm showing 324, okay. Wow, it's not 325, it's 324. I don't have to go back with pencil and paper. I can type in 324, and I've got a new number, okay? You see there's not dramatically different than 325, but it's different. 136.14, let's go 325. 136.25, okay. And so not a great difference, but do you see that as long as you're in between 300 and 325, you've now got an answer for anything. How about 301? That's darn close to 133.6, isn't it? And what if you do exactly 300? The interpolating formula gives you exactly 133.6. What if you want to put in exactly 350? You get exactly 138.9. Okay. And so my suggestion is, do you see that Excel can be your friend? If you set up your own friendly little simple Excel file, you've got a little bit of a way to fat finger in some numbers for homework problems and quickly interpolate linearly between those two numbers. So that's a way to do it. Calculator is another way to do it. You certainly want to be able to do the calculator approach in order to do quizzes and tests, but looking ahead to other classes that you'll take, you might want to consider using this, okay? Or in practice, certainly in your engineering practice, when you get out and get a job, you're going to find that you're going to be using software platforms a lot more than you're going to be using pencil and paper and a calculator. And so you're going to be, I believe you're going to be leaving the calculator behind and moving more towards a PC or tablet-based engineering work approach. Okay, I think now it's back to PowerPoint. I think I've covered what I want to cover in Excel. Let's go back to PowerPoint and see if I can start my show again. Okay, we've gone live. Okay, so you can possess that Excel file by clicking on this link. Go to Jay's Toolbox. Let's say search for interpolation, and then you can download Interpolation Demos 2022. Now, looking ahead, you're saying that's pretty simple. I don't think I need to go to Excel and learn more about Excel just for that interpolation. I do want to foreshadow some things that I have ahead that I'm going to want to present, some videos yet to be created about using Excel to determine thermodynamic properties of water and steam, air, refrigerant, there's some others, ammonia, and CO2, that I'm going to show. I'm planning to show you how to access some work I've already done and or create the work on your own, either way, so that you can really use Excel to your great advantage, both in, let's say, working on homework problems, but further, once you get future classes, perhaps, or when you're out on a job and you really want to quickly evaluate thermodynamic properties of these substances, you can quickly get to that rather than the drudgery of going to the back of the book and looking down numbers in tables and writing them down and going to a calculator. So looking ahead, I hope for you to be able to unwrap all these gifts that are shown on the screen, but you've got to understand the fundamentals. You've got to understand the basics before you just start blindly using someone else's work and you really don't understand what's going on. Okay, so what are the takeaways from this work? One is it's easy to create a basic interpolation table in Excel. You don't need to copy and paste mine. You can do this on your own. It's useful for homework problem solving and beyond. Okay? Of course, a reminder, be sure that you understand how to do this task on your calculator as well for good performance on quiz and test taking. And also stay tuned as I'm going to try to create some more videos related to thermodynamic property lookup tools in Excel. So that's it. I hope you've gotten something out of this. Give this Excel a try. Give it a try. The more you use it, I think the more you will like it. And the more you practice at Excel, the better and better and better you will get at it.